All right, so let me remind you what we did Thursday, and then we're just finishing this, well, as much as we can today. We still have a bunch of problems left. But Thursday, what we did is find area between curves. And the idea is you just take the area under the top one minus the area of the bottom one, and then you're left with the area between the two. Okay, so we did a couple examples, one where the graph was given to us, and one where we had to make the graph. But the idea was always the same. You do the area of the top minus the area of the bottom. Okay, and that will give you the right answer. Okay. All right. So here's where we left off. Find the area between negative x squared plus 4x plus 2 and just x plus 2. All right. Okay. So let's do that. Do you guys have any memory on how to start graphing these? Or actually, we did something before we started graphing these. You guys remember what that was? Yeah, find out where they're going to meet. That'll make your graph. Okay, so let's do that. Intersect. Let's find out where they intersect. It's kind of side work, but you do negative x squared plus 4x plus 2 is equal to x plus 2. Okay, and then you go about solving that. Okay, so let's do that. I see a plus 2 and a plus 2, so if I subtract 2 from both sides, then they'll cancel, and I'll just be left with something simpler. Okay, and then once I get here, let me ask you what to do, just to make sure you still remember. You guys remember, because I have an x squared and an x, what you should do? Yeah, Jake. Yeah, what are you talking about? Add what? Yeah, you want to get everything, so James is saying add this x squared to the other side. You want to get everything to one side and factor it. James, I'm actually going to do the opposite because it's less work. I'm going to bring this guy over here, but you're right. Let's get everything on one side, and 0 on the other. So I subtracted x from both sides. I'm left with this. Then the point of that is you have common factors of x now that you can factor out. And now you have something times something equals 0. So either the first factor is 0, x equals 0, or this second guy is 0. Negative x plus 3 equals 0, meaning, again, x could be 0 or x could be 3. Okay, so let me box that off. That was just side work. All right, okay. And then this is helpful because now you can just graph the basic one, the easier one. Okay, that would be a line with a y-intercept of 2 and a slope of 1. That's a y equals mx plus b, in case you forgot. Okay, y-intercept of 2, slope of 1, that should look something like this. Okay. And then, like I said, having done this pre-work makes my other graph easier because even though I don't know exactly what this parabola looks like, I do know, okay, it's a parabola, it opens downward because of the negative, and it intersects this line at 0 and 3. Okay? So it has to intersect it here at 0 and here at 3, and I know it's a parabola opening downward, like I said, so it should look something like this, putting those pieces of information together. Nice. All right, cool. And so now it's very clear what the area is. It should be this area between. And we'll set up the integral for that after this question. Yeah.
How do you know that?
Because it was negative to start with. This x squared was negative. Nice. Okay. So now let's set up the integral. You guys remember how to do? Like you guys tell me. I'm going from where to where first of all. And I know you guys know it. Yeah, Jake. Yeah. 0 to 3. Okay, and then it should do top minus bottom, so what's my top function? Just making sure you're all good. Well, first of all, I hope you agree that my top function is my parabola, yes, so which one of these is my parabola? Yeah, the x squared one. Okay, so top function should be the x squared one. Negative x squared plus 4x plus 2. Minus bottom function is the line. Minus x plus 2. Make sure you put that in parentheses or you'll miss a negative, like you won't distribute a negative. Okay, cool, you're subtracting off that whole function, that's why you need the parentheses. Okay, and then, I don't know, I guess it would be good to do some of these by hand. I don't think I want to do this one by hand. If you were to simplify everything, maybe we do one step. If you were to subtract these things, then you get negative x squared, which doesn't combine with anything. 4x minus x is 3x, so plus 3x. And then 2 minus 2 is 0. So you get this integral, which looks a lot friendlier. Okay, then you anti-differentiate, you plug in your stuff, and you get, yeah, I don't remember, let me check. Okay, like I said, everybody knows, I hope, how to do these integrals by now, so let me skip the actual in-between work. If you were to do this, you should get 9/2 as your final answer. Okay. All right, this next one might be good for you guys to try, just to see how much you know. It's a little bit complicated because of the square root function, but see what you remember. Try it yourself. Try it yourself. Okay, try this and see what you understood. A lot of people were stuck in my last class with what this graph should look like. Remember, the square root of an x function, the parent function for that just looks like the top half of a sideways parabola. So this one will just be that shifted up and maybe a little bit steeper, but that general shape. Okay, and then ask questions if you're stuck. Otherwise, I just kind of assume everyone gets it. Okay. I'm seeing like most people, I've seen only one person not do this. So be really careful. Once you get to this point, okay, you set them equal to each other. But once you get to the point where you cancel these out, and you're here, I'm seeing a lot of people bring the x over right now, but it'll make your life easier to square both sides right now to get rid of those square roots. So square both sides, and you get 3x equals x squared. And now bring them both together. Okay, that's all I'll say. You keep trying. Yeah, okay, good. Yeah, and then this is annoying to deal with. Well, I won't say. See if you Okay, all right, let me catch up to where you guys are. I'll start putting that work down. Okay, from what I saw, most people are there. Okay, and then this one is one that I think is good to do by hand because I think most of us forgot about how U substitution works or when to look for it or whatever, and you're gonna need that. So let's do this one by hand. Okay, so first of all, let me say, if you got to this point, like exactly like how I have it, then really good work, great job. You did all the hard work. Now this is about dealing with an annoying integral, or actually kind of two annoying integrals. Okay, let's simplify this. That would get me 0 to 3 of square root of x plus 1, and then minus the 1. I would just be left with square root of 3x. The 1's cancel like I just said, and then minus x. Okay, then the reason I was talking about U substitution is because look at this part, you guys. This has a function within a function, which is annoying, and but luckily it's just a linear function, 3x. So that's a good hint that this is going to be like a simple U substitution type problem. But let me actually split it up because we're only doing U substitution on this function, not this minus x as well. So let me split it up into two parts of the same integral. Let's split it up into the square root part, and then this other part. Oh shoot, minus this other x, so minus 0, 3x dx. Remember, that's something you're allowed to do if you have function plus function or minus function. You split them up like that. Okay. Then, like I said, this part makes you frown because it's U substitution. But hopefully it's not hard. It should just be annoying, but like I said, not hard. Let me do the U substitution up here because I'm out of room. Okay. U in that case would be, well, let me ask you guys, what do you think U should be? It is what you might expect. Yeah, no. Yes, okay, good. Yeah, just 3x, not the whole square root. Okay, because then that way your du becomes 3 dx. Nice, okay. But you're only trying to replace 1 dx, so you divide by 3. Okay, and you get there. Okay, and so now this turns into, do I have room? No, probably not. Let me start a new line. Now this turns into the integral of u du, actually, sorry, square root of u du with a 1/3 out in front. Okay, the 0 to 3 I'm intentionally leaving off because these are x values and I don't want to convert them to u values right now. So I'm just gonna go back to x's later. So I'm leaving those off because I want to be really precise. Okay, and then this minus 0 to 3 of x dx, that did not require u substitution. Okay. Now, all right, let's keep going. That would be 1/3 integral of u to the, or sorry, square root of u is u to the 1/2. Du, and then I'll mess with this integral later, so minus 0 to 3 s dx. All right, I keep going now. I have 1/3 times, okay, antiderivative of u to the 1/2. That would be, okay, I add 1 to it, I get u to the 3/2. And then I divide by the new exponent of 3/2, or in other words, I multiply by 2/3. Okay, that's what I'm left with. The u1, and then minus this integral, which I'll do that later. Because I'm almost out of it. All right. And then now finally, don't forget to go back to x's so that you can plug in your 3 and your 0. Or, like I told you before, you could have turned these x values 0 and 3 into u values by making them go through this. Like multiply both of them by 3. But I didn't want to go through that. Okay, so I go back to x's now for u. And let me do two things. Let me do 1/3 times 2/3 is 2/9. Times u was 3x to the 3/2 minus this other integral. All right, but that other integral, let me just do it right now. That is x squared over 2, remember? Okay, and then I'm plugging in 3 and 0 into this one and 3 and 0 into this one. So actually I could just put 1. I'm evaluating this as 3 and 0 into both x's. Okay, now the plugging in, I think I will skip because that is, I mean, not that interesting and not something you need to remember. You guys know how to plug stuff in. So if you were to do this and you plug in these numbers, you get, I lost my key. There it is. If you do this correctly, apparently you should get 1.5. That's not bad. Does that seem reasonable? That would be, yeah, 9. Square root of 9 is 3. Cubed is 27, but divided by 9 is 3. Times 2 is 6. This becomes 6 minus 9/2. Yeah, okay. That does seem right. Wait, what's 9/2? 4.5? Yeah, okay. So that does make sense. All right, we did it right. Sweet. All right. So these are kind of intro cases. These are the basic cases. Sometimes, though, you get more annoying cases, such as this one. Look at how these two graphs, if it told me, okay, get the area between these two graphs, it would be a little bit tricky because these intersect not just here and here, but also at a third point. Okay, so for that one, you have to account for that. And in most of these cases, or I can't think of a case where you'd intersect 3 times where something like this doesn't happen. Where, look, on the left, on the purple region, the top function is blue, and is this blue x cubed function, and the bottom function is this red x squared function. And then this blue region, it switches. Red is on top and blue is on the bottom. So, what I'm saying is you're going to need to do separate integrals for this left part and for this bottom part, or for this blue part, because top and bottom switch in each one. So that's what this is talking about. Write a separate integral for each area that you see. Okay, so let's do that. Let's do that for this one. I'll probably skip the actual integration, but let's set up the integral. All right, this purple section, if I want to set up that integral, that would be the integral for just this purple section. It looks like I'm going from -2 to 0. Those are the two balance of it. Of top minus bottom. Okay, top here is blue, which is, oh, here it is. It's 2x cubed minus x squared minus 5x. So there's the top function, 2x cubed minus x squared minus 5x, minus bottom function, which is this blue, or this red one, x squared plus 3x. Remember to put parentheses for it when you subtract off a whole quantity. All right, and then remember that's just the purple section. Now you need the blue section as well. Okay, so now you need to, okay, I have my purple section. I need to add on this blue section. So plus, the blue section would be what? From 0 to 1, it looks like. 0 to 1. Okay. Of top function is red, which is this x squared one. Minus bottom one is this blue one, 2x cubed. Okay. Do you see why I have two integrals? Where I'm getting these numbers, where I'm getting these numbers, why these are switched? Anything I can explain better? Okay, and then now this one just makes you roll your eyes, but hopefully it doesn't, like that doesn't look too hard. It's just two integrals of polynomials. All right, so it's annoying but not hard. The way you do this is, like I said, it's just two integrals. So let me go down where I have more room. I'm going to do this integral, plug in my numbers, this integral, plug in my numbers, and then add the results. Like I said, two problems in one. Okay, so let's do that. That would be -2 to 0 of, this simplified would be 2x cubed, and it's -x squared minus another x squared minus 2x squared. And then minus 5x minus another 3x is minus 8x. Yes, that's my purple section. Then I do the same thing over here. Now it's my integral from 0 to 1 of x squared minus another x squared is, or sorry, x squared minus -x squared is, those add now, so it's 2x squared. Then 3x minus -5x, that's plus 5x, so plus 8x. And then what am I missing? The minus 2x cubed. All right, then like I said, you do this integral, plug in your numbers, this integral, plug in your numbers, and then add the results together. All right. I don't think I want to do the integrals. Like, these are polynomials, you guys can handle it. It's just going to be a lot of annoying work. Let me skip that. Are you okay if I skip that? You guys know? Okay. Yeah, let's skip the this stuff. You know how to do it, okay? To do this integral, you would get this. Okay, this integral turns into this after you plug in all your stuff and everything. This integral turns into that after you plug in all your stuff and everything. and then you combine all those fractions and simplify everything, and you get 41/6. All right, okay. So that's nice if you're given a graph. The next one, unfortunately, does not give you a graph. Okay, so again, this is more like it's more annoying than it is hard. But okay, let's go through it. Let's do the annoying work. Okay, so first of all, it would be nice to know what, like the graph of this, because that way I would be able to set up my integrals right away, but I don't. So I have to make my graph. The first step to doing that is, well, just to make sure you guys are with me, what would be my first step? What would be a helpful first step before I make my graph? Yeah. Find out where they intersect. Find out where they intersect, so set this equal to that. All right. So there's an equation for intersections. Then I start solving this. I see minus x squared and minus x squared. Those will cancel. I'll be left with 3x cubed minus 10x equals 2x. Then again, I have an x cubed and an x. I want to get everything together. Let me know if this is too fast, but you guys know how to solve it. I subtract the 2x to get everything on one side, then that equals 0. Okay, then these both have a 3x, a factor of 3x that I can pick up. Okay, and then you're good to stop there, or if you like to factor, you could even factor this difference of squares. Get to that point. Is that too fast? You guys go over your with me? Okay. All right, okay. All right, so then that means that it looks like I will have 3 intersections. One at 0, one at -2, one at positive. So it's either this is 0, this is 0, this is 0. Okay, x equals 0, x equals -2, x equals 2. Okay, so like I said, this is just helpful side work. Another helpful thing to have would be a graph of this so I can tell which one's on top and which one's on bottom. Or even, should we not even do that? Because remember how I told you it doesn't really matter if it's on top or on bottom. You can just set up your integrals guessing which one's on top minus the bottom. And if you get a negative answer, just make it positive. So I don't know if you want to do that or not. That's kind of like, yeah, let's not do that. Let's be formal and good about it. Let's make our graph and see how to graph these, what the graph of this looks like. Okay, so we make our own graph. Which one of those looks simpler to graph? Probably the parabola. So let me graph this one kind of like with fidelity, like a little bit precisely, and then this one I'll just graph around what I know about my parabola and my intersection. Okay, so if I want to graph this one kind of accurately, then like I know it's a parabola with that opens downward. It would be also good to know the vertex of it, and then that's probably good enough. Like I can make my picture from that. So do you guys remember how to find my coordinates for my vertex of a parabola? Yeah, this is one that is like not super intuitive. It's hard to remember. You learned it way long ago. But the x coordinate has something to do. It's kind of like the quadratic formula. Less time, any guesses you guys remember? All right, the x-coordinate of your vertex of your parabola there's a way to figure it out by using your a's and b values. It's negative b over 2a. That'll give you the x-coordinate of your vertex. Okay, so in this particular case, it looks like the x-coordinate will be, don't want to crowd my graph, so let me do it down here. The x-coordinate will be negative b, which is negative 2 in this case, over 2 times a, which is negative 1. So negative 2 over negative 2, which is 1. Okay, there's the x-coordinate, and then the y-coordinate, obviously, you get by plugging it into your function. Okay, so my y would be plugging in 1. Okay, that would be 1 squared is 1. Negative that is negative 1, plus 2 is positive 1. So it looks like my vertex is at 1, 1, x, y. Okay, cool. So let's do that. 1, 1. Okay, we'll call that 1, 1. All right, and then I know that it opens downward, like this. So from this point, I'm just going to kind of estimate. Doesn't have to be super great. I'm going to do it like this, and like this. Okay, negative 2, I'm going to say around here is negative 2. This is 0, and this is, I'm going to call 2 like around here. Yeah, actually you could do something, yeah, what are you going to say?
I was just gonna say the, like, slope, I guess, is just negative x, so it would go to 2.
Yeah, that's exactly what I was about to say. If you do a tiny bit of thinking and like if you want to make this a little bit more precise, you can see that this is, like the coefficient in front of the x squared is just a 1, so it's just going to go like how you would, like a normal parabola. It's going to go, the first step is going to go down 1 over 1 and down 1 over 1. So actually we do know that it's going to cross right at 0 and right at 2. If you didn't notice that, it wouldn't really matter. But just to make our graph super precise, we could have it going straight through 0 and straight through 2. Yeah, good job. That's good too. Nice. Okay, and then now that we have our simpler function graph, now we can do this cubic function. I have no idea what this actually looks like, but I do know it's just a cubic function. Oh, and like it's a positive cubic function. So it should look something like that, like whoop, like this. And on top of that, I know that it should intersect at 0, at negative 2, and at 2. That's why I made these, that's why I plotted those. I made a point of making them. All right, so at negative 2, looks like I'm way down here, at 0, and at 2. And I know I have to look like this shit, because that's what cubic functions look like. Okay, so, I kind of estimate, looks something like this. And there I get a pretty good graph. All right, nice. So now let's set up our integrals and then let our calculator do them. Like I said, hopefully none of that was hard math. A lot of it might have been like hard to remember because it's been so long. But yeah, it's just more annoying math than hard. Now we actually get into the calculus. Like, no, only now are we getting into the actually solving the problem. But let's do it. All right, it looks like I need 2 integrals because one's on top and one's on bottom here, and then they flip over here. So the left half of it would be the integral from, let me check with you guys, from where to where should I go for this left half? -2 to 0 sounds good to me. Nice. Then what goes inside my integral? What minus what? Nice, nice, nice. Okay, good. Yeah, it should be the cubic function because that's on top of minus the black function, the parabola. So cubic function was 3x cubed minus x squared minus 10x minus the bottom function. Black function was negative x squared plus 2x. Okay. And then again, like I said, these are annoying because that's only half of the fun. And you still need to set up this integral, which should be this same thing but flipped in different bounds. So I'm going to run out of room. I've got to write these down here. So plus the right half would go from 0 to 2. And now it's the parabola on top, so this one minus the cubic one. Okay. And then if you're looking at that being like, oh shoot, that's going to be super hard to do by hand, it's not. You guys look, it's just all, it's a polynomial. This is a polynomial. Even if you don't simplify it at all, it's just polynomial. So I'm going to skip that part. If you put that into a calculator, you did it by hand. Oh, watch this. Then you actually get 24 just straight up as your answer. Kind of weird. Okay, cool. Then just for fun, I think I graphed these. Let's see how close we were. Pretty close, there it is. There's the parabola, there's the cubic one. Cubic one is more like extreme than we graphed, but it's like got the same similar thing. All right, nice. This is where I stop with fifth period, so let us stop there. We're gonna be a day behind Mr. Little, but that's okay. We'll finish this Monday and then start the rest. Yeah.
I have a question about the
Okay. And let me stop the video.